So this question, again, you need to figure out what your interpretation of the problem is going to be. So this gives us a position. But we are looking for the minimum speed. So there's a few things we have to do here and a few interpretations we need to make. But let's start first. How do we get the speed?
You get the derivative.
The derivative, the change in the position. And one reason I think, too, these questions are common is you'll notice I'm repeating what we did in question 18, but you'd already have that work in front of you in your exam, right? So you could reuse your work that you previously did. So this is giving us not quite the speed, but be more specific. It's actually giving us velocity here. The reason that matters is because velocity can be positive and negative. Speed is just a scalar. For example, somebody driving, from here, I guess we'll say if east was negative and you're going towards Chilliwack at, minus 120 kilometers an hour on the freeway, your speed is much faster than somebody going through our school zone at 30 kilometers an hour west. Even though we write one of them as positive 30 and the other as negative 120, the negative 120 is much faster. But it's a speed that's faster, right? So when you hear the word speed, it's important that you think speed is like the absolute value of velocity. You just disregard any sign that you have. Okay? So it is something you need to pay particular attention to when you read that word on your exam questions and Barron's. The answers might not make sense to you if you're thinking of speed as having positives and negatives. So if we want to minimize the speed, what do we need to do? Don't be shy. Minimize and maximize. What's your strategy? Come on, it's critical points, which requires a derivative, right? We got to find a derivative, so let's go again. Maybe I'm not asking the questions clearly today. Okay, so we're finding the acceleration. That's going to help us figure out where this velocity could be maximized. So we get a critical point out of this at time 2. And that shouldn't be of surprise to you. We already looked at the graph. We already had a number line for speed. So again, if you were doing this question, I'm trying to do them, building them as a separate entity. But if you were doing this question that we've already talked about, you could carry your work on. You already have a number line here, and you know that it's positive, and here it would be 0. So that shouldn't surprise you that you end up with a critical point there. It means my speed is increasing, I'm 0, and then I keep increasing again. So it goes like this, I would assume. And then it stops for just a brief instant, and then the velocity keeps increasing again. So there's a, critical point to try. And it tells us that when I put in I end up with 0. So this, in fact, is going to be where I have my minimum speed, because we said that the velocity is positive for every value. The only thing smaller than a positive is 0 if we're ignoring the sign, right? Otherwise, if it could be like, as I said, if it was negative, we'd have to consider that. But in this case, the only thing we can do is sneak under those positives with a 0. And that means I'm going to have my minimum speed at time equals to 2. So that is B.